Bismillahirrahmanirrahim. Greetings. This is going to be continuation, this lecture, of the previous lecture, in which the goal is to find a mathematical formula for a finite sum of 1 square plus 2 square plus 3 square and so on and so forth. Now, in the previous lecture, we examined that if we do know the input set of a function and the output set of that function, we can determine the rule of correspondence between these two sets. Now, we examined that one in the previous lecture. Now, we are going to use the very same analogy for this lecture to find a possible function which leads us to the formula of the finite sum of 1 square plus 2 square plus 3 square and so on and so forth. We don't know such a function exists. We are starting to examine from scratch, from the ground zero, to find if there is such a function exists. Now, the input set of our function in this case is a set of non-negative integers, 0, 1, 2, 3, 4, and so on. And the output set will be the sequence of partial sum. Partial sum of what? Partial sum of the sequence of 1 square, 2 square, 3 square, and so on and so forth. Now, by the way, I'm using set and the sequence interchangeably in this particular lecture, but I have already mentioned in my first lecture that there is difference between sequence and set. But in this case, for this particular example, they both are same, because the sequence satisfies the properties of the set or sequence. All right then, let me stay out of your way. I put them on the board so that we can go discuss that one in writing. May I please? All right. Now, let me see if I can be a bit more explicit in a sense. This is the set of my input. The sequence of 1, 2, 3, and 4. This is the set of what? Of 1 square, 2 square, 3 square, 4 square, and so on. That we are trying to find the summation of them, a formula for that. And this is the set of partial sum. Partial sum of what? Partial sum of 1 square plus 2 square plus 3 square and so on. So I wrote it in compact form, and I also read it in a more kind of explicit form. Do you follow me? Now, I have that one written also again to be kind of more explicit. Okay, now here again, the input are what? Are 1, 2, 3, 4, and so on. This is this set, this sequence, and the output are sequence of partial sum. I've already shown that. Now, look what are they? Let's just discuss this one. What is input and output of a function? The input are the points on the horizontal, geometrically. The inputs are points on the horizontal axis, and the output are points on the vertical axis. Is that right? No. Our output on the vertical axis, I have put it here, I hope that it is visible. And the difference of any two successive points, he tells us, he gives us information how the function is behaving from the first point to the second. And then from that point to the next, again, the difference will tell us how that function is behaving. That's exactly what derivative of a function is. When we take the derivative of a function at a certain point, it tells us how the function is behaving at that point. What is the rate of its increasing or decreasing or staying constant, depending on the function. The derivative tells us that information. That's exactly what we do, but because this is not calculus-oriented lecture, so I'm not going through the calculus to interpret that now, but going through these differences. Now look what happened. The difference, look at this one. The difference of these points on the vertical axis is quadratic. You see that? From 0 to 1, it goes 1 unit up. From 1 to 5, is going, the second point is 4 units away. So the function is going 4 units up in the vertical axis from 1 and 5 in there. And then from 5 to next, which is the partial sum, we know that, will be the function is going 9 units up. Now look at that. Look at this. These are data, these are the outcome of a quadratic function, isn't that? Quadratic. So that gives us very strong conjecture that this data, the points on the vertical axis that I mentioned, this data, the sequence of partial sum, should be from a polynomial of degree 3. Do you follow me? And then when I go further, look at that, what happens? The difference of difference. Look at that. From 3 to 5 is going 2 units up. From 5 to 7, again 2 units up. From 7 to 9, again 2 units up. You see that? Therefore, this is the data that comes from what? From a linear function. This is the output of a linear function. So that means this is quadratic, and since this is quadratic, this should be a polynomial of degree 3 that we are trying to hopefully succeed to find. Okay, now let me also, well, what we notice also, let me say also this one that we already covered from the previous lecture. Now, look at the appearance. You see there is a lot of similarity. Look at the way that it looks. The difference and difference and difference, we end up to 0, and we end up with the same thing, 0. You follow me? And I did that also for polynomial of degree 3 in the previous lecture. Look at that. There is a lot of good similarity. Difference of difference of difference, you end up finally what, to 0. That's exactly is happening here. You see that? So that makes our conjecture a little bit even stronger, that this data, the output, should be coming from a polynomial of degree 3. All right? So let's now see how we can possibly find that one. So what is a general form of a polynomial of degree 3? It is ax squared, of degree 3 is ax cubed plus bx squared plus cx plus d. This is the general form of it. So what we are trying to do, to find what? To find A, B, C, and D. So I have put that one in writing, and let me go over that for you. Okay, now let me also, if I may, to cover this one, so that, now here, our conjecture was that we are dealing with a polynomial of the degree 3. And this is the general form of a polynomial of degree 3. So we are now looking to see what A, B, C, and D are. So in order to find them, we already have the input and output. So we plug input and output and see what we can come up with. So I go to the next. When I get to my function 0, not function, excuse me. When the input was 0, the output was also 0. You remember from the data we had? So if we put for input 0 for this function, we get what? We get 0, 0, 0, we get d equal to 0. Fantastic. We already found our d. Now we have to find a, b, and c. So we need 3 equations with 3 unknown to determine a, b, and c. So how do we find? Exactly again, same thing. The function, when I give when the input was 1, the output was also 1 from the data that we had also. So we put for x1 and we end up with this equation. We call it equation 1. A plus b plus c equals to 1. Now, the second one was that when the input was 2, the output was 5 from the data that I took off previously. So I put for x2, I get 8a plus 4b plus what 2c equals the output, which is 5. That is my second equation. Now I need the third one. The third one, when the input was 3, the output was 14. Remember from the data, previous data? So I put for x3, I get 27a plus 9b plus 3c equals to 14. This is my 3 equations. So I have 3 equations with 3 unknown, so I'm going to find my unknown. So I go through the elimination. This first equation, I multiply by 2 and add it to the second one. That eliminates c from these two. All right. Then I multiply the first one by -3 and add to the third one. So I eliminate this one. So I'm left with 2 equations with 2 unknown, which will be much easier to determine. So I have put that one in writing. So let's see. I multiply -2 by equation 1, add to equation 2, and I do -3 times equation 1, add to equation 3. By doing that, I eliminate c. So, and that gives me 2 equations with 2 unknown. Let me now go through that 2 equations. So I have put that one in writing, and okay, now here, as I already mentioned, I multiply this one by -2 and add to that. So you see that -2 and 2c, they eliminate. So I'm left with this equation, which is 6a plus 2b, which is 1 equation with 2 unknowns. So I need the second one so that I have 2 equations with 2 unknowns. So then I multiply this one again by -3 and add to the third, to my third one, and I end up with this equation. Right now I have 2 equations that I marked them a little bit with red for better visibility, and that from 2 equations, 2 unknown, I can find my A and B. So I'm not going to continue because it's grade school arithmetic, multiplication and addition, but I want you to do it yourself and also check it with mine. So by doing that, I end up my A to be 1/3, I end up my B to be 1/2. Once I find A and B, I can plug here to find my C, and my C end up to be 1/6. Now, then this gives me what? Gives me now I can plug, now I have my A, B, and C, so I put to that general form of that I had it. So let me cover this one. When I put for my A 1/3, because you see I wrote n instead of x because the input and output are non-negative integers. So we are working with natural numbers in a sense. So I put n. So when A was 1/3, here it is. B was 1/2, here it is. And C is 1/6, this is it is. So this is my formula, finish, bingo. I found the rule of, I found the formula that I was afterward. But in order to make it a bit more appealing to the eyes, I modified that one. So they have a denominator of 3, 2, and 6. The least common multiple of them, common denominator is 6. So here it is 6, and I add the numerators. So I end up with this formula. You see that? And then I factor n out, and I end up with this product. And this one I open two parentheses, and this end up to be these two product. So I factor, I use, a very elementary basic algebra that you have a plus b times c plus d, a squared plus 2ab plus b squared, that kind of, identity that we are familiar with. So I end up with these three factors. Do you follow me? Divided by 6. So the general formula of that, of the summation of a finite of that, is this one. Fantastic. So let me zoom this one back. Okay, then I'm so excited. This is the beauty of mathematics. It gives you wing. You see, Ali is flying. So I don't want to go further. I don't want to hit my head on the ceiling. But mathematics gives you wing, and that is true. If it is taught correctly, and also if it is learned correctly. So my sincere advice to all my students at all the time is please, please, please do not follow recipe. Critical thinking is very important in learning mathematics, and try always to justify and try to start from ground zero to build up what you are after for. And that's exactly what we have done from all this. This was the sixth one in the series that we are working about the sequence and series. Okay, then I thank you all for watching. I hope that my uploading my videos are beneficially. I'm doing that for the benefit of the public, for my fellow American first, and for any other part of the world that they may be watching. Hopefully it is beneficially, and I'm not expecting any thank you, and just you learn from it is reward to me. Okay, then again for the second time I thank you for watching, and as always I wish you prosperity, good health, and good good health, and please stay safe and remain safe. So in closing, as always, I salute you. I give you an army salute and say so long.